Welcome to this webinar on AI and academic publishing. What does the future hold for authors, readers, and publishers? It's a pleasure to chair this webinar, and we have with us today a brilliant panel that represent very many different groupings that are all relevant to the topic. I will introduce the individual panel members later when we come to each of their presentations. After the short round of presentations from the panel, we will have a general question and answer session. So those of you who have questions, please put them in the Q&A box. Please make your questions as concise as possible. It becomes difficult if it's a very long treatise. And we will then deal with them in the discussion period that we are going to have. Just now, I just want to say a few remarks about the organizations behind this webinar and a few general remarks about the topic. So Academia Europaea is a Europe-wide academy, as the name implies, founded in 1988. Members are elected by a quite critical election process and are leading scientists and scholars which are active in Europe. Uniquely, Academia Europaea, unlike the old national academies, is a kind of distributed academy which operates through a number of so-called knowledge hubs throughout Europe. You can see them on the map. And one of these knowledge hubs is the one at Cardiff University, which is behind the organization of this particular webinar. The other organization that is behind this webinar is SAPEA, which stands for Science Advice for Policy by European Academies. It's an organization that is basically composed of 5 European networks. Academia Europaea is one of them. ALEA, or European Academies, is another one. IASAS, the Young Academy organization in Europe. FEAM, the Federation of European Academies of Medicine, and the Federation of Engineering Academies in Europe. They, together with the chief scientific advisors, which we'll come to in a moment, are the European Commission's scientific advice mechanism. The SAPEA organization produces evidence review reports in response to questions coming from the Commission. And on the basis of these evidence review reports, you see quite a few of them signposted here on this slide. The chief scientific advisors pronounce the scientific opinions, which will then be a basis for decision-making by the European commissioners. So the process started in 2017. You see there some of the people who were present at the first meeting of the group of chief scientific advisors with the SAPEA board. Since then, of course, there have been many exchanges. In fact, virtually all of these people have retired or finished their term. And we now have a new group of chief scientific advisors, which you see on the board here. And today, for this webinar, we have the privilege of having 2 chief advisors with us. We have the chair of the group of chief scientific advisors, Professor Nicole Grobert from the University of Oxford, and we have Professor Alberto Melloni from Italy. I will introduce them in more detail later. So they are the ones who, on the basis of the evidence review reports that I just highlighted, will draw out the specific recommendations for policy. And then it is obviously up to the commissioners what they want to do with these recommendations. Now, a few remarks about the topic today. Artificial intelligence, often regarded as the study and development of computer systems that can copy intelligent human behavior. And as the great scientist George Buzaki has emphasized, our species is very distinct and special in the way that we are able to externalize our brain function. And AI is, of course, just the latest example of that process. However, as he also pointed out, one of the kind of drawbacks of this ability that we have uniquely in the animal world is, of course, that our individual share of the ever-increasing total knowledge is exponentially decreasing. And if we sort of extrapolate widely, we could actually think of a kind of future where all scientific papers are written by AI and are read by AI, where maybe we as human beings don't have a place anymore. Nevertheless, at this moment in time, AI is not that great. And Buzaki has also pointed out that our brain is pretty impressive, actually. We have the hippocampus, which effectively is an excellent librarian for all the information that we have stored in our neocortex, and is able, amazingly, very quickly to separate the irrelevant from the important in a matter of just a few search cycles. So there is probably still quite a gap between what is possible for our brain and what is possible with AI. I had a recent experience with AI. I was a member of an international panel evaluating Hungarian research network institutes earlier this year. And AI was used at the very end to bring everything together and to formulate final reports and recommendations. But I have to say that there was not a uniform satisfaction how the system worked, actually, and there were many contradictions in the AI-generated report, which actually had to be ironed out by human beings. A recent editorial in Nature also has pointed out that maybe scientists put too much trust into AI, and that this could be a problem in the sense that there is a kind of tendency now for many people to think that all problems will somehow be solved by AI, and that may not necessarily be the case. But we will come back to that, and certainly challenge the panel to think about these things. Everyone is making recommendations about AI, and so it is not only SAPEA and the group of Chief Scientific Advisors who do so. The G7 Science Academies have issued statements prior to the G7 summit this summer in Italy, and has also again pointed out that there are a number of serious risks. And one of the main problems at the moment is the traceability of the data used in AI models, which is obviously critically important, but because most of the development work is done in the commercial world, we very often don't know actually how things were done. So I will conclude these brief introductory remarks now, and we will move on to the first presentation. And we are very happy to have with us today Nicole Grobert, who is the chair, as I already mentioned, of the European Commission's Group of Chief Scientific Advisors, and she is also professor of nanomaterials at the University of Oxford. So the floor is yours, Nicole. I will stop sharing.
Thank you very much, Oli, for this very kind introduction and great overview. So I'm here today to share with you the content of the scientific opinion that we produced on the request by Executive Vice President Vestager and Commissioner Ivanova. And the question they have asked, the scientific advice mechanism, which Oli nicely introduced, it's a concept where you have the evidence review report produced by SAPEA, and then the scientific opinion generated and the recommendations generated by the chief scientific advisors. So the question they have asked us is how AI can be taken up in a responsible way to create an environment where Europe is keeping its competitiveness, global competitiveness, and how can we get all researchers on board? How can we make sure that they are trained in AI skills, that they have fair access to the best AI tools, computing power, and data? How can we make sure that AI helps us to create research that is more impactful than ever before? And also, how can we ensure that the researchers are actually aware of the information that is necessary to deal with any legal or ethical issues? in terms of also general well-being and just fostering responsible use of AI. The idea is to have Europe as the place to be to run research using AI as a tool. So what do we need to put in place today that this is actually going to happen? And people are using AI as we speak. There is some people have more awareness and are more used to using AI, and there are other researchers who are less experienced. Yet it's basically coming towards at the speed of light. Publishing is affected. So we need to have the right skills to make use of this, the right use of this. So really what the research or the GCSA has highlighted is that we need to create the right environment. We need to create an environment where researchers of all disciplines, not just the typical suspects, should receive information on where and how to access AI tools specialized for research, and also that applies to publishing. And scientists do need help to deal with any legal and ethical issues related to AI on research, AI in research. And what is important is to basically establish communities and transdisciplinary collaborations between the different scientific communities so that these scientists can learn from each other. The group has also highlighted that all researchers need to have fair access to state-of-the-art AI systems that includes data, computing, and codes. And yet, access alone is not sufficient. It will not suffice because scientists and AI systems require high-quality data. So we need to ensure the quality of the data is the best as is possible. This is necessary to ensure transparency and also the reproducibility of the research, which Ole has also just highlighted. So it is absolutely critical that the scientific methods are transparent to ensure that the science remains excellent and we don't get false information in data. The critical aspect here is that much of today's data sits actually in the hands of the private sector. And therefore, the Commission needs to really come up with very creative approaches to public-public and public-private partnerships to make this data that sits in the private sector available for researchers with AI for the public good. And the group of chief scientific advisors actually stresses that the need for AI tools that are tailored to the different disciplines. So different disciplines will have different requirements. And this is to help all researchers in Europe to stay at the forefront of research and internationally competitive. So for example, a physicist will have different requirements from, for example, to historian. And these tools need to be adapted. So we need to really have concerted efforts to develop these tools between the data owners and also the existing and future computing powers and infrastructures, so that there's this ecosystem that works together. And we need the close collaboration between developers of AI, so those people who develop AI, but also the scientists who want to use AI and those scientists who also still need to learn how to use AI, as well as the private sector. And really what it boils down to in the end is that we must seize this moment now. It's now the opportunities are about, and if we don't do anything about it now, then we'll lose actually. And therefore, it is quite important for the Commission to deliver on these ambitions, that they put frameworks in place that can evolve with this very fast-moving field of AI and AI in research. And for this, what we ask them to do is to look into flexible and dedicated funding mechanisms to invest for research with AI, and also to establish a publicly funded and state-of-the-art distributed institute for research with AI, which we call EDIRAS. It's a European Distributed Institute for AI in Science. And besides that, alongside this institute, there should be a council, AI in Science Council for all scientific disciplines, with AI. And of course, as it's developing so quickly, there needs to also be an EU node that allows the continuous monitoring of both the potential of the technology, but also the risk that may come along with it and any developments. So this also applies to publishing, and I'm sure that the chair of the SAPEA working group, Paul, I believe, who is now after me, will go into greater detail to discuss that aspect. Thank you.
Well, thank you very much, Nicole, for summarizing the recommendations from the scientific opinion to the European Commission. This is very helpful indeed. So we'll move on to the next presentation by Dr. Anita de Waard, who is Vice President for Research Data Collaborations at Elsevier. And so, Anita, the floor is yours.
Thank you so much, and it's a great honor to be part of this this group. Can you see my screen?
Yes.
Okay, great, thank you. So I'll briefly say a few words about generative AI specifically and its use in publishing. And in only 5 minutes, it's very hard to do it justice, but hopefully we can cover some of these topics in the Q&A later. And within Elsevier and RELX, which is Elsevier's parent company, we've been thinking and working on and with AI for quite some time. We publish some of the preeminent journals, but I also have over 200 data scientists. And so we're very involved, intrigued, and working with it. And I wanted to highlight a few key concerns, key opportunities, and some things that we are doing. So some of the key concerns, of course, that we have as a science publisher is that much of the generated AI is inaccurate and does not rely on reliable sources. Many of the AI bots that are out there are not trained on scientific content, and they scrape the web, and honestly, they can't make any difference between a serious work of science and a piece of text. That also means that they could not be up to date. Elements that are used to generate content from can be outdated, they can be refuted, and of course they can be extremely biased. And furthermore, they can be homogenized. So when you take a summary of 20 views, when there's a very interesting discussions and there are pros and cons, there's a big risk if you take all that content and flatten it, that you get very homogenized content, which really bypasses both scientific and political and possibly societal issues. So it's not a good reflection, even if there is science at the basis of it, of what the science was really about. We have huge concerns about ethics and biases. As you may be aware, there is a huge crisis ongoing in scholarly publishing right now concerning research integrity issues. So there are fake papers that are created by generative AI or that are created by humans, but that are not based on any actual research. And we see these exploding with the advent of ubiquitous generative AI tools. There are also non-ethical publications. So for instance, publications that seem unbiased, but are in fact skewed by political or financial means, and that don't reflect the non-biased views that a scientist could or should have. Similarly, there can be papers that are promoted or shared if some of these pieces of work are, for instance, authored by a political group, then they can promote them and using tools and algorithms really make them seem as if they are true, as if they are very widely distributed. And of course, all the advent of AI tools can lead to bias. Again, there's no time to really go into any of the details, but the content can be biased. The choice of authors and editors and the choice of papers that get published can all be biased by AI tools. And lastly, we're quite concerned by the environmental impact that these huge computers can have and are already having on the planet. On the other hand, we also see that there are some tremendous opportunities that AI brings to scholarly communication. Simply put, AI can improve the quality, but also the creativity that exists in research and scholarship. Linking articles to their data, to software, to workflows. These are all things that we're striving for. It is really all hands on deck, and AI tools can help with that tremendously. The acts of writing, reviewing, and editing can be absolutely supported and improved by AI. And I only need to mention that it's a bit bizarre that people are still editing references to in this day and age. Surely we can have tools that can help us with that and not waste our critical brain power doing things that machines are much better at. And also enabling connections between disparate topics. So if you look at collections of work, you can identify topics in a very creative way using AI technologies. Also using knowledge graphs, which I'm sure Paul Groth will talk about. So utilizing existing AI technologies, connecting them to thinking that has already been going on in computer science for the past series of decades can really enable new forms of scholarly communication. Also, AI can improve the public trust in science. We have been working with a group called Sense About Science in the UK, and they have a campaign that's called Ask for Evidence. And we are very interested in enabling a larger audience to enable the tracing of claims. So if you see a claim, say, in a news item or in a public document, you should be able to trace it back all the way to the scientific evidence behind it. It can also help support researcher in communication. We're doing a project with Sense About Science to see if we can help train researchers who, as a study that we did together with them last year showed, have increasingly the sense that they need to spend more of their time explaining the validity and the truth about science. And so we're working on a program to support researchers in communicating their research. And of course, it enables the explanation of any concept, equation, or other piece of science as you develop bots that can go behind the phrase, that can go behind the math, that can go behind the data. Lastly, we do believe that AI itself, apart from having concerns on ethics, it can also improve equity and inclusion. We have a number of projects where we're using AI tools to identify and combat sources of bias in our own, say, reviewer recommender tools, or in the ways that we identify institutions or authors to go ahead and get published. It can enable access to a broader range of communities, and for instance, translations into other languages or into styles such as a less scientific style are right around the corner. So we are doing a number of things directly to address the concerns that I just mentioned. We absolutely support the EU AI Act, but we also have a series of responsible AI principles that have been developed by our parent company, Reed Elsevier LexisNexis. And they're listed here. We consider the real-world impact of our solutions. We take action to prevent the creation or reinforcement of bias. We can explain how our solutions work. We create accountability, and we respect privacy and champion robust data governance. And we are extremely vigorous in sticking to these principles. Any tool that uses AI that is developed within Elsevier's wider remit and RELX's remit, we need to fill out a data card that identifies how and where we actually follow these principles. We're also working with the AI community to identify fake papers. There's a challenge for detecting automatically generated scientific papers that will be co-hosted with the Association of Computational Linguistics meeting in Thailand in 2024. The challenge is still open, and we've generated a set and identified a set of fake papers. And the challenge is to computational linguists to identify these and to help us and the scientific community as a whole detect whether or not a paper was written by a human being or was solely written by AI. And we have a series of guidelines for authors, editors, and reviewers, as well as developers. There's much more here, but again, time won't allow me to go into it. Regarding authoring, we say that authors are allowed to use generative AI and AI-assisted technologies, but only to improve the language and readability, and we ask them to disclose such usage. We do not allow editors to use generative AI or AI-assisted technologies to assist in the evaluation process of whether or not a manuscript gets accepted, because we believe this is a purview of humans. There's a great risk of bias, and there's a great risk that the technology will sort of run amok. So that's an area where we think that AI, we're putting a pause on utilizing AI there. Also, I must add, we are not allowing either our editors or our authors to upload full text manuscripts into any open AI tool, just to make sure that the manuscripts that have not been approved do not disappear into the crawlable web space, to make sure that we will not enable the spread of incorrect information. And lastly, any of the AI technologies that we use conform to these responsible AI principles, as I mentioned, and a great focus is there on conducting completeness and plagiarism checks, and also preventing bias. Lastly, I'll briefly say a few words and then I'll stop about some of the work that we're doing currently. We are looking at AI as a front end for some of our key tools. Scopus, which is our abstracting and indexing service, has an AI front end that we see in very, very heavy use, where you can basically have a conversation with Scopus. Clinical Key AI just got featured on Bloomberg News. That is, again, that's our information for clinicians. And it allows a clinician to ask a question that they come across in practice and receive an answer. In both of these tools, it's very critical that we always identify the references, and the user can directly jump to the piece of edited and screened content that is scientifically valid, that goes behind the recommendation. We're also working on new approaches to our full text search engine, Science Direct. We're looking at using AI to thorny issues such as improving the detection of plagiarism and falsified images. There's a lot of work happening there also with our partners at STM and other publishers. We're looking at improving the quality of our content, things like descriptions of experiments and protocols, and for instance, having the units of measure of every paper be clearly defined at any point. And lastly, we've just started on a project to support the draft of policy briefs, which we'd love to talk to some of the people on this call about. How can we support the better support of science behind policy briefs? And are there any efforts that can be done now? And lastly, I just want to say we're working with and for research to help invent the future. The characters on the right are Muppet Labs, where the future is being made today. We really see that we are partners with the future. We're looking at networks of persistent identifiers. We're looking at new formats, such as the content profile linked data, to allow a better access to various parts, more granular parts of scientific content. So I'll stop there. Thank you so much.
Thank you very much, Anita, for this comprehensive account of what Elsevier is doing. Is very interesting indeed, and we'll no doubt come back to many of the special issues during the general discussion. We'll move on quickly now to Alberto Melloni, who is a member of the European Commission's Group of Chief Scientific Advisors. He is Professor of the History of Christianity at the University of Modena, Reggio Emilia, and a holder of the UNESCO Chair of Religious Pluralism. So, Alberto, the floor is yours.
Thank you very much. I will bring you in a different world. It is the world of humanities. And I will start recalling to you the story that maybe some of you are familiar with, the story of the inductivist Turkey of Sir Bertrand Russell. The Turkey that was making proper observation, collecting evidence of the fact that each time and each day at 9 o'clock food is coming, and making the wrong assumption that this will last forever. So we may wonder what the Turkey with AI could do about his expectation for the future. But the problem is that in the field of humanities, we have a different set of issue working. And the problem of AI for humanities is that we work in an inductivist world. We call evidence and sources things that are different. And for this reason, humanities are bringing a different set of questions if compared with the area of health or science or physics or material. But at the same time, humanities are in a very different position in this moment, because usually when it comes about new technologies, humanities are considered more or less like the ugly duckling of science. Our science are doing the good use of technology, and the humanities are working only with what is the remaining aspect of what is technology bringing. In AI is a different set of things, because as we know, and also as we pointed out in the opinion that we wrote for the European Commission, AI is a technology that has a very peculiar status. What we call in the opinion the AI system, namely data, codes, and computing power, can migrate from one field to another one. And this makes of the humanities, even the more narrow scientific sectors, something that is fertile for the knowledge of other things, industrial process, and also scientific publishing. As it already been said by Anita, AI is affecting the publishing flow, the production, the capacity to detect false things. Even there are very interesting stories in this in the humanities. But mostly, it is affecting all an area of critical work concerning text and objects. If you think to the difficulty of making things like this one, in the stemma of manuscripts that we can detect in different libraries, creating the structure for a critical edition and bringing us as close as possible to the original text of an author, it could be Aristotle or Shakespeare, that makes many differences. This is an aspect in which AI is creating a great impact, and the type of codes that have been used, that can be used for making manuscript detection is very interesting, because it's more or less the same that we use in intelligence and in countering terrorism mechanism. This use of AI is changing what critical edition are doing, but at the same time, they can be part of something that is very important for us, namely the fact that we work on objects that are bringing to us challenges coming from other aspects. Here in the slide, you have two objects. On one side, you have a cuneiform tablet. It's 5,000 years old text written in the first type of alphabet that we have. And in the world, there are only 2.5 million tablets. And for decades and centuries, the way of managing this type of object was more or less very complicated by the fact that tablets are scattered all around the world. Some are in places that are not available for the scholars. On the other side, you will find fragments of papyri, finding in the garbage, actually, of Cairo. And these Coptic fragments that have been sold to tourists and collectors for centuries are these two scattered everywhere. And to collect and to manage this type of things is impossible for human activities in this moment. But through digitization of these objects and AI management of these few letters that you see in this fragments, is possible to make greatly forward in terms of knowledge. For this reason, I think that the use of AI is a great challenge for humanities and for publishing humanities, because on a certain level, it gives a good reason for what is the result of previous research made even in manuscripts in centuries. And on the other side is making the critical aspect of what people is doing more available for a new generation of scholars. The use of AI in the humanities, so to conclude, is a way that, in my view, could be important to bring scholarship in this field far from the idea of the ugly duckling that I was mentioning, and bringing even humanists and scholars in the humanities on the front line of the relations between technology and research. Thank you.
Thank you very much, Alberto, for making these very valid points, which I think are really quite important. I think there are great opportunities actually in the humanist area. The last presentation in this round will be given by Paul Groth, who was a member of the SAPEA working group on AI in science. He is professor of informatics at the University of Amsterdam in the Netherlands. And we look forward to hearing from you, Paul, now. Please unmute.
Yeah, sorry. Hi, everybody, and thanks for the introduction. And I would just wanted to kind of reflect on the evidence review report that we did for SAPEA and try to pull out some key findings, particularly for the publishing industry around AI and what we found in the evidence review. So I think one thing that made this review particularly challenging, and also I think when we think about science in general, is that AI is really a general purpose technology. And that's one thing you really have to recognize, that you can apply and use it throughout the entirety of many, many domains, and including the research lifecycle. Indeed, within the report, we found many examples of where AI was used across the research lifecycle, from actually generating experiments to producing hypotheses, and across many domains, from physics to astronomy to the humanities. So some particular areas where AI is being used, or you see signs of use of AI for that impact publishing, is one, automated idea generation from literature. This is, for example, reading all of PubMed or reading large corpora of literature to produce the connections that Anita talked about. Indeed, we've been working with Elsevier personally in my own personal capacity to do automated hypothesis generation from the literature. We see people using automated workflows, so actually people automating whole labs, and that has an impact in terms of the production of knowledge, and then how do you convey that knowledge and the impacts of that on open science. And lastly, I think the one that's kind of most obvious to all of us is kind of the dissemination of research outputs. So you can think here about the ability to produce high quality summaries of the literature, to automatically extract references, to automatically produce points or summaries, to produce translations of the literature. So across all those domains in that evidence review, we're seeing this application of AI. And the interesting thing is that we also see this idea of AI as an accelerant, and it can be an accelerant in a good way. We can produce many more hypotheses, we can do potentially many more experiments, but also in terms of publishing and information quality, as Anita already mentioned, there's the problems of just bad information. So the overproduction of just junk, right? On the other side, there's the need of, the term is called code captures. So the idea that for publishers in particular, you're producing or helping scientists and researchers put their information out there, and also from the lens of open science, that the value of that doesn't just go to the researchers themselves or the scientific community, but it's captured, right? It's captured by other entities that are taking and using that information. And AI accelerates that process of, okay, we open things up and other people may acquire value from that. Throughout the evidence review, and especially with this idea of AI as an accelerant, the importance of scientific rigor came up. So how do we guarantee scientific rigor, especially as more and more research takes advantage of AI tools? Many of those tools are private or aren't available for things like reproducibility. How do we document that correctly when you publish? And in general, also to combat this idea of a low information quality that might be accelerated by the emergence of AI. So I encourage you to read the evidence review. I also think the policy recommendations coming out hopefully are very useful for what the EU decides to do yet. But the review is quite interesting if you want to get a whole view of how AI is impacting artificial intelligence and science in the EU. So that was my little intro there. Thanks.
Thank you very much, Paul. That's very helpful. We have a fifth panelist, Kira McNeice, who is a research data manager at Cambridge University Press, and she leads Cambridge University Press strategy and activities related to open research. She has not wanted to give a presentation as such, but given that she hasn't had an opportunity to say anything, I just wonder whether, Kira, you would want to very briefly kind of state whether you're in agreement with what your colleague from Elsevier, Anita, was saying, or whether you have some additional or contradictory view, just very shortly, and then we will move quickly to the general discussion. Kira, you have a few minutes.
Okay. Yes, no, thank you very much for having me. It's been a really interesting discussion, and I'm looking forward to the broader general discussion. I don't think I have anything particularly contradictory to add. The way that we've been thinking about AI and how it affects publishing here is mostly that it's not really offering new kinds of qualitative challenges so much as exacerbating some of the concerns and issues we've had with things like fraudulent papers, as Anita mentioned, and accelerating issues with spreading bad information and poor information. So generally in agreement with what the other panelists have said. Yes, and I think what this really highlights is the key importance of how we validate the integrity of scientific research. How do we actually ensure that we're making sure that the things that we publish and the things that people are reading in academic journals are valid research and based on real research. So even if an AI system is being used to write up the paper or assist with writing the manuscript, the most important thing is that the science itself is sound and that we really hone in on peer review and decision-making by editors that are all still done by humans, again, as Anita said, because it's crucially important that we assess the validity of these scientific results and research outputs.
Okay, thank you very much. We have a number of questions from Isatu Sa. Some of them may relate to things that have already been mentioned, but it may be nevertheless good to start with the first of those. So he or she, I'm not quite sure which, writes, how can AI-powered language editing and plagiarism detection tools improve the quality and integrity of academic manuscripts? I think we have already had quite a bit of discussion about that. But may I just add from what I understood from Anita, was that at the moment Elsevier is not recommending to use AI tools for reviewing of papers. And I can understand to some extent why that is so. However, it seems to me that some of the frequent errors that certainly I come across as editor and reviewer are, for example, using references that actually do not contain the information that is claimed in the text. And this is particularly serious for review articles, which of course play a dominant role in science these days, simply because of the proliferation of this. There it seems to me that that is somewhere where AI really could be helpful to editors, because you can capture things, you would be able to see that actually that reference that a particular author is using simply does not contain any information at all about that particular topic. So why not allow that? Maybe I misunderstood you, but...
So I would love to answer that question. And you can see that both Paul and I started grinning as you continued your question. This is because we completely agree with you. And in fact, the collaboration that Paul mentioned called the Discovery Lab, that is a Dutch AI effort between the universities and Elsevier. There are many such efforts in Holland, but within the scope of that, we have been working on exactly the project that you suggest. In fact, we're looking at how can we identify which sentences or segments of a cited paper are actually being cited. So you're looking in the citing paper maybe if you mouse over the reference, you see the most salient text snippets or the most salient table or image that is being referred to directly. And we actually worked on that exact project. It's great to hear your thoughts on that. And absolutely, we think that's something where AI can absolutely help. And it's not to say that there is no role for AI tools in editing or checking manuscripts. We absolutely think there is. What we want to say is that the final decision to accept or reject the paper rests with the authors. And I think that's what Kira said as well. So I don't know if
sure.
you have
No,
additional
I totally
points. Yeah.
absolutely, of course. But yes, indeed. There is another question here from an anonymous attendee who says that the speakers have talked about the fallibility of AI systems. This is not to diminish issue of confabulations. However, to what extent do our speakers believe that we are holding AI tools to a higher standard than we might hold humans to? I don't know who wants to address that question.
I'll take that.
Okay.
Maybe, but I think when we design automated systems, it's we often want them to perform better than we do. And I think in some sense, I think the question here is how much, and I think this you saw in the evidence review report, and also I think a lot of the way thinking in the EU context or what you see with some of our collaborations is this idea of hybrid collaborations, right? That AI systems are a tool that we need to use, and the responsibility lies with us. And I think that's the kind of frame I would go for. And I think it's up to us to expect our machines actually to perform really well. And that's one of the hard things about developing ML-based systems or AI-based systems is that you have more, it's not just a system that you probably, there's always bugs, but we have to design systems that work with us and help us improve our system performance as a whole.
Thank you. There's another question from possibly another anonymous attendee or the same one. And the question is, speakers have talked about bias within AI datasets. Could speakers talk about how they are assessing bias within AI datasets? I don't know who wants to pick that up. Maybe it is Paul again to start.
If you want, I can something on that.
Okay, fine.
It is an interesting question because when we speak about bias, of course, we think about misguiding ideas written in the dataset feeding the system, and not only in the hallucination coming from the system itself. And I think that in this sense, the idea that was also mentioned by all at the beginning, the idea that there is the risk of an excess of trust in the mechanics of AI is, for a certain point of view, a very comforting information. There is still a role for science and good science and research to be capable to detect and to smell where the bias is. Because the bias is not only the fruit of something that is created by an eagle scholar, but is something coming from people that has nothing to do with this type of thing. Simply think to the gender bias in the type of literature that comes from the past and how this impact on the cancel culture that is growing in our moment, historical moment now. And so this is the part in which artificial intelligence need human wisdom to be moderated and mitigated in a proper way in order to detect and to suspect where the bias can be.
Okay,
I would want to chime in there and just say that I think this frame of AI as an accelerant is really a good frame to adopt here. So in some sense, we have bias in the scientific system because everybody is kind of biased. And one of the nice things about science is that we are open and we try to reproduce things, and slowly we get to a better answer, right? And I think one of the ways we can target bias, if there is to really clearly document the kind of data cards that Anita mentioned, document the data that we train AI systems on. It's one of the calls in the evidence review report to have that ability to see into, hey, how did you train that AI system? What did you use? And then we can determine together, is this appropriate for the research that we're doing? And so I'm very heartened by things like the Content Authenticity Initiative, which is really about documenting that kind of whole pipeline, the transparency around what models that we build and where the data comes from that's used by those models.
Can I just add something to that?
Yeah, sure.
We keep talking about training AI systems, but we also mustn't forget that many researchers who are embarking on using AI for either publishing or their research do also need to be trained on how to use it and how to read the output and how to assess the output and how to pick up on the bias. Those antennae need to be opened.
Yeah, it's an important question, this one on bias. Anyone else who wants to comment on this?
I have a brief comment. So we look at bias in the data itself, but also bias in the algorithm and then bias in the applications. And all three can play a role in bias. As an egregious example of bias in data, I was involved in a workshop with the AAAI back in 2021, where we looked at the data that went into facial recognition systems. Where you see that, for instance, something like gender identity is incredibly biased because the underlying data was coded in such a way. In one data set, the data was coded as man or attractive female. And those were the two genders that were coded in the data set that was used to train all sorts of other things. So that's an egregious example. But you can also have tools that work perfectly well, but are used incorrectly. And another example is in Holland, in fact, the cabinet fell because an AI tool was used to identify people who might be fraudulent in getting support from the government, and the outcomes of those tools were used without any further criticism. So I completely agree with Nicole. It's not just that there's bias in the data, there can be bias in the algorithm itself, but in the end, it's important that the humans that are utilizing these tools are aware of and trained to spot this bias.
And if I could just tack onto that, also looking back at one of the previous questions about whether we're holding AI to a higher standard than humans, I think ultimately we're still asking humans to be responsible for the decisions that are made. Like, you don't want the AI to be just taken at face value like that. And, the same thing with authorship of research articles. Someone can use AI in their research, they can use it in the writing of their manuscript, but they have to declare it and be transparent. And that human also has to take ultimate responsibility for the content of the paper and for the content of their research. So yeah, I think ultimately it's that we want to hold AI to exactly the same standards we hold humans, and that someone has to be responsible for decisions made.
Okay, thank you. There's a new question from Ian Bryson, who says, many thanks for excellent and inspiring inputs. I am not sure whether this is relevant to this discussion today, but I am a bit concerned about Eurocentricity in a world of deep inequalities, that this focus on AI might exacerbate these inequalities. Secondly, I hope we can consciously try to ensure that real intelligence can be recognized over artificial intelligence now and in the future. I'm not quite sure about that one, but does anyone want to?
Perhaps I can comment on the Eurocentricity. That's simply a result of the Commission asking the scientific advice mechanism, what can Europe do, to be at the forefront of making best use and ethical use of AI in research to help research be internationally competitive, because developments are happening worldwide. It's a global challenge, as you point out rightly. So that's where the Eurospin comes from. But of course, what we're talking about applies to global.
I want to add something on about particular about inequality, but in particular with inequality with respect to access to AI systems, right? And this is something that was noted in the review report, namely that if AI is being used more and more across research domains, access to state-of-the-art AI systems become then a prerequisite for being able to do science and also being able to reproduce science. And then the problem comes with the fact that such AI systems are extremely not accessible to everybody because they cost a lot of money to build. And depending on which news reports you're reading, you know, frontier AI models are costing billions of euros to train, right? And then the question is, who has access to that? And then that kind of puts people in positions where they can do science other people can't reproduce or can't help. We already see this in the scientific endeavor of computer science, where research labs that are funded by large tech companies are able to progress much faster than other academic scientists because of the availability of resources. And now the question is, if AI is a general purpose technology, does that start to impact the rest of science? You can see some of this with things like AlphaFold 3, right? Which is fantastic, but the people who are able to train that kind of model are a large multinational tech company, right? So this is a one part of inequality, but I think an important aspect of inequality for AI.
I want to ask a question of Nicole, because I know that Nicole has to leave very soon. So you mentioned that you would like Europe, so to speak, to be the best place in the world where research on AI goes on and so on. And some people have been a bit skeptical about that and saying, well, I mean, but the big developments have been in the US and China. At least that is a general perception. So since you are sort of closer to the Commission than any of the rest of us, is it your impression that the sort of amount of investment that the Commission will want to make will actually be able to change that so that Europe actually will be leading in this field?
Well, we advisors, can't really go into the budget of the Commission in detail, but we have been shouting quite loudly that substantial investment will be needed, and the request for this dedicated institute for AI in research that hosts everybody doing research with AI, and alongside this, substantial funding to make this research happen and also the training of the researcher happen. This is a very loud outcry for substantial funding towards that goal. What the Commission in the end decides is not really in our hands.
No, I fully understand that, of course. Anyway, thank you for this comment. There is a new question from Nadi Statler, who's a PhD, and she says, could you comment on whether emerging AI-related issues mentioned, for example, fake papers, are being more or less evident or prevalent to originate from some regions of the world versus others? If relevant, how could education empower researchers and decision makers to mitigate negative impacts and improve trust in science long term? I mean, basically all questions overlap a bit with what we have talked about, but nevertheless, that's another formulation of the question. Wonder whether anybody would want to say anything about that. Doesn't really sound
I think Kira and I are looking at each other.
okay.
Do you want to say something, Kira? Otherwise, I will.
Well, you can go first if you want.
Either way. I would not like to say that specific regions of the world are more prevalent than others. And in particular, I think this is an area where, bias is just around the corner. I do think that it's clear that that it's important for all science publishers, but also the entire scientific community, to wonder why people spend money and effort and run companies to generate papers that are not science. They're just made up. And it's clearly an outcome of the way in which scientific outputs are evaluated. So I think it's a global requirement that we start thinking about evaluating science in more interesting ways, frankly, and in ways which cannot be like this, turned into a cat and mouse game, where people try to pretend that they have done work and published a paper purely for getting promotion or tenure or gaining some financial advantage. That's not serving anyone, I think. A bunch of people are nodding, so I'll hand off.
I was going to say this almost links to the next question a little bit about assessing scientist performance and criteria for assessing scientists. Like there are a lot of improvements being made to evaluation criteria. We've got, the San Francisco Declaration on Research Assessment, where we've all agreed we're going to stop looking at what journal something's published in as an indicator of the quality of the research, or that we should be. Yeah, so I think that comes down to the way that we evaluate science and the way that we reward these practices, because the system as it's set up is created to reward quantity of publication in a lot of cases. And so making sure that we have proper evaluation systems in terms of how researchers and their careers and their outputs are measured, and the impact of those outputs are measured and rewarded through employment or through promotions, I think that's going to be a key part of it.
Well, I would absolutely agree with that. It also relates very much to the last question that has just come in, but still it's formulated in a particular way, so it may be worth answering it specifically. Juliana Popescu writes, many open access journals do not use AI-based tools for detecting plagiarism or image manipulation. However, we are encouraged to go with open science. In assessing a scientist's performance, any criteria makes reference to what kind of journal have you published in. So how can we solve this dilemma? I would add as a personal note that in a biomedical world in which I work, we have, of course, always and continue to do so, paid enormous attention to which journal things are published in. And we do in practice, whatever people say, use this as a very important filtering mechanism. Clearly, a paper published in Cell counts, generally speaking, for a lot more than one published in the North African Journal of Biology or something like that. So we can't deny that there is this, and to some extent, I have to say, at least in the huge biomedical science world, we do need actually to do that. Still, it's an interesting question, and maybe it's not a bad one to sort of just have as our final question. So I don't know who wants
to say. I don't see this distinction between open access and non-open access journals as a key one. I believe currently all of our journals are at least possible to be open access for sure, and we do plagiarism checks on all of them. It is true that there is, just as what Paul was mentioning for researchers, also for publishers, there are inequities. We can't all have, 50 data scientists working on detecting plagiarized papers. So one of the efforts that scientific publishers are conducting is through the STM organization. There's a research integrity hub that makes tools available to all publishers, whether or not they're a member of STM. And I think such efforts to enable open access, open source tools to detect plagiarism and sharing between funders, between infrastructure providers, between institutions and publishers of persistent identifiers, like this researcher indeed works at this institution, or this institution got this grant. Those enable us to develop systems that would allow checks that would make it easier and better for everyone to participate, including publishers that are not as well funded.
Yeah, I was just going to say the exact same thing about open access versus non-open access journals. I don't think that's necessarily the indicator of quality. That's not telling you anything about how rigorous a journal's checks are. And I would argue, in fact, that once an article is published open access, there's so many more eyes can be put on that article, so many more people can see it. And the more people who have access to and can read and evaluate an article, the more likely we are to spot bad science or fraudulent practices, because it's out there for everyone to see.
So I'll take one. This is not from the evidence review report. This is more my own take, and it's a bit far out take. Is in my very positive days about AI, and I can be very positive about AI, is that it can enable us to actually move towards an environment where we look at complete reproducibility and rigor in automated systems in many sciences. So we not just read your paper, but in combination with open science, open data, open code, we would be able to automatically take down your what you did as your science, automatically reproduce that in a cloud lab with an AI, right? And that's kind of a vision of the future where actually that whole part of reproducibility of science, we can just check your work because everything's made available. And then we get to a different measure of science, not a science based on, hey, I published in this venue, but a science based on, hey, you did that actually good science. And I can automatically check that it works, and it works in different environments. So that's a vision of the future that I hope we get to. I don't know if we will, but for me, that's open science and AI kind of flipping the script on how we evaluate research today.
Well, in some subjects, you may be absolutely right, but of course, in many subjects where we are reporting results of experimental work done in a laboratory, of course, your computer systems will not be able to check whether these data are valid or not. But that's not an argument against what you're saying. I think the tools obviously can be very helpful up to a point. One thing I think that probably will be extremely useful for any kind of paper is simply using AI to check internal consistency in manuscripts. This is quite a hard task for many reviewers, actually, to detect inconsistencies. But it seems to me that AI would be a good tool to actually simply check, are there things in the manuscript that are intrinsically contradictory? And this, I think, is something that should be used. I had a specific question to Anita, actually, before we finish. We are really already over time now. Could it be the case, or might it be the case in the future, that different publishers, simply because, as you said, you cannot have 50 AI workers checking every single manuscript, that more efforts and thereby more resources and more money will be put into checking manuscripts in the more high-profile journals that, for example, Elsevier publishes, of course, a wide range of journals from Cell at the top to other journals that are sort of perfectly fine, but not necessarily regarded as so important. Would Elsevier develop a policy whereby it feels compelled to sort of spend more effort and time on checking manuscripts in what are papers that actually pay more for Elsevier, because you get larger sums of money for papers published in these top journals? Maybe it is not a question you would like to answer.
No. I honestly have to say, I have not heard of any plans or any thinking in that direction at all. I do want to refer back to the previous point, because I think what's incredibly interesting and what is a very interesting development is having AI work together with types of logic that have already been developed. For instance, there's chemical logic. So any chemist can see whether a reaction is valid or not valid. Even a student of chemistry can already see that you've dropped, an element, or you've dropped a 2. Similarly, in mathematics, any physics bachelors can look through all the equations in most of our articles and see whether or not they're valid. And similarly, I would think in biology, there are things that are possible and not possible, again, in cellular interactions. I don't know enough to validate that, but I think it's incredibly interesting to explore the interaction between such systems of logic. Units of measure is a very obvious one that I care about a great deal as a physicist. I actually think that utilizing AI there, in any case for us, would mean that we would apply similar scrutiny to all journals. There is a lot of editorial effort on, say, the Lancet papers that is done where every paper that has a clinical trial in it gets checked against the protocol of the clinical trial. So even papers that are rejected get intense human scrutiny. And there is a difference between journals there. But I actually think that AI will do the opposite, will make a lot of these opportunities possible for journals that perhaps did not get adequate editorial scrutiny, and so kind of level the bar, raising all the boats for all the publications. So I'm quite hopeful there.
Well, that sounds very positive, and maybe that is a good note to end on, because I do think that both in terms of the checking on references and the internal consistency, there are very great opportunities. I mean, I've come across several papers in my own area where the mathematics, for example, is straightforwardly wrong. And what you mentioned is that should have been easily detectable by an AI system. So let's hope, and also the optimism of many of the rest of you is infectious. And let's hope that the positive aspects really will overwhelm all the potential dangers that are in this area. It's a huge topic, and of course we have only scratched the surface in this webinar, and we may well come back to that in many future webinars, I suspect, because it's an important issue which will be with us for years. So I really want to thank all of our excellent panelists for incisive comments, excellent contributions. And thank you also, Nicole, for having stayed with us a bit longer than we might have expected. So hopefully this is a sign that it was interesting. And we still actually have almost 100 participants with us at this moment in time, which is a clear indication that this webinar actually has been of great interest. So it just remains for me to thank particularly the Cardiff team, who have done all the work for this webinar, Julia Davis in particular, but also Louise Edwards and SAPEA for having co-organized what I think has been an extremely interesting occasion. So thank you very much indeed for your contribution, and thank you to the audience for having stayed with us longer perhaps than we might have expected. So I close this seminar now.
Thank you.
Thank
Thank
you
you very much.
Very much.
Thank you.
Bye-bye.